Okay, so we will be using calculators on this. We're going to start today with something called trigonometry. You may have heard of that. You may have seen some interesting buttons on your calculator. One of them is SIN, that is not sin, it is sine, which you see written out SINE. One of the buttons you may have noticed on your calculator and had no clue what it's for says COS. That means something called cosine. And there's another button on your calculator abbreviated TAN. Or you may have on the Inspire, you may need to push the trig functions, and then it will give you a whole bunch of things, including these. And we will be defining what those are. I'm going to get my calculator to load as we go through this. So these are special ratios for angles, and all we are going to do in this course is write triangle trig. Next year in Algebra 3, you'll start learning about trig for other angles. But right now, this year, it's just special ratios in right triangles. So if you don't have a right triangle, you cannot use trig yet. So if you look at this triangle, you notice that I have labeled one angle as B, and I've labeled one of the, well, I've drawn it so that I've got a right angle, and one of the acute angles I've labeled as B. So it does not matter which angle I talk about. The hypotenuse is, of course, always the angle that is across from the right angle. And so we know that because we've had the Pythagorean Theorem plenty of times before. And it's also the longest side of all three. Now, once I pick one of the acute angles, so not the 90-degree angle, I've got two other sides of the triangle. One of them is right next to B, and we call it the adjacent side. One of them is across from B, so for B, that is the opposite side. However, if I had picked the other angle, so now I'm going to call that A up here, the hypotenuse is still the longest one. But now for A, this side down here at the bottom that is across from A is A's opposite side. And this side for A is right next to it, so it is the adjacent side. So adjacent and opposite are totally dependent on which angle you choose. Now, as far as what these ratios are, I've got two triangles with 90-degree angles marked, with 30-degree angles labeled. So how big is the other angle? Somebody unmute and just say it. How big? How much? It's going to be 60 degrees. So these are similar triangles, right? They're both 30, 60, 90 triangles. So when you have similar triangles, let's start thinking about some ratios. For 30 degrees, let's talk about the opposite side over the hypotenuse. So on this first triangle, the side across from 30 is 2, the hypotenuse is 4. So we get 2 over 4, which would reduce to a half. Okay, in your chat, how long in the other triangle is the opposite side? So type in the chat for me and go ahead and hit enter. How long is the opposite side? And hit enter. So how long, which side is the opposite one? So 60 is indeed the opposite side. The hypotenuse longest side is 120. Is that also a half? And that's going to be true for any 30, 60, 90 triangle. The opposite side over the hypotenuse will always be a half. And that fits with our definition of similar, is that for similar triangles, all of the angles match up and are the same. And the ratio of the sides is going to be the same. So we would have expected that because of knowing that they're similar. So a couple of things to notice about this. The longest side is always across from the right angle. That is going to be our hypotenuse. Also, the shortest side is always across from the smallest angle. On the first triangle, 2 was the smallest side. On the second one, 60 was the smallest side. The smallest angle was 30. The 2 and the 60 were across from the 30. The middle side is always going to be across from the middle angle. That isn't specifically trig, but that is something that will help you with some of the problems that you'll see. In that case, the 3.464 was the middle side. It was across from 60, the middle angle. 103.92 was the middle side. It was across from the 60-degree angle. Okay, we also noticed that the ratio of the opposite over the hypotenuse was a half on both of those, and it will be the same, sorry about that, for any 30, 60, 90 triangle. That ratio is what we are going to call the sine of the angle. It is going to be the opposite side over the hypotenuse. That will be true not just of 30, 60, 90 triangles, but any right triangle. Again, this only works on right triangles. No other triangle has a hypotenuse. Other triangles will have longest and shortest sides, but no other triangles will have hypotenuses. So you can only do this with right triangles. These are ratios that we are going to want to memorize. I'm going to give you a little saying that'll help you remember which one's which. So for this angle, once I pick one of the not 90-degree angles, I can think about the opposite side, the adjacent side, and the hypotenuse. Sine for this angle will be how long the opposite side is over how long the hypotenuse is. Cosine will be how long is the adjacent side over how long the hypotenuse is. Tangent will be how long the opposite side is over the adjacent side. And the way that we remember that is SOHCAHTOA, sounds kind of like a Native American word or something, but what that means is that sine is opposite over hypotenuse. Cosine is A for adjacent over hypotenuse. And tangent is opposite over adjacent. So just a little saying to help you remember that. And I think you've pretty much got that written down, but just make sure, don't worry about these numbers. Just to make sure that you've got that down and understand what that means. I've got it here on this slide again. You will want to be memorizing this little SOHCAHTOA relationship so that you know which one is which. And then I'm going to start showing you how you work with this. Some of these we will do with no calculators. Some of these we will do with calculators. And I don't see any questions or slowdowns or anything like that coming up in the chat. So let's go ahead and try our first one of these problems. So here we have a right triangle. And they tell us we're going to use this angle. That little symbol is called theta. That's one of the Greek letters. So they just picked that and named that angle theta. So if we want sine, cosine, and tangent. So sine, and we have to have an angle there. There's no such thing as just SIN. It has to always be sine of some angle. It needs to be SOHCAHTOA. It needs to be opposite over hypotenuse. So type in chat how long the opposite is over how long the hypotenuse is. And hit enter for me. And good job, the opposite side is 5, the hypotenuse is 13. So far, so good. Next, I'm supposed to find cosine of theta. So ca, that means I need adjacent over hypotenuse. And I'm in a little bit of trouble here. I know the hypotenuse is 13, but I don't know how long this adjacent side is. Who can help me out? Unmute and tell me what to do. How can I figure out how long that side is? Because we've got a right triangle. So when we have a right triangle, we can still always use Pythagorean Theorem. So we can either recognize that as a triple, and let's see, I'll call that A for adjacent. I know that a squared plus 5 squared has to be the hypotenuse squared. So if I take 169 minus 25, that means a squared is 144. So how big is A? 12. Or some of you know 5, 12, 13 is a triple. So that means my cosine is 12 over 13. Okay, that leaves tangent. So tangent of theta needs to be opposite over adjacent. So write in the chat the fraction for this. Opposite over adjacent. And hit enter. Great job. So opposite is 5, adjacent is 12. So we didn't need a calculator on that at all. Anybody with questions so far? Okay, there's another kind of problem that you're going to have. And it will look like this. This is still a no calculator problem. It says sketch a right triangle. So any direction you want, it can, have the right angle on the left or on the right, top or the bottom. And I'm going to label it, that's my right angle. And then I need to pick one of the other two angles. So I'll pick this one over here and call it theta. It tells me what letter I need to use. Right now, I don't know if that is drawn to scale or not. That's okay. I don't know if the shorter leg really should be across from theta or should have been right beside theta. Maybe I should have picked this angle up at the top as theta. When we're doing this kind of problem, it does not have to be drawn to scale. But we draw a right triangle, we label one of the angles as theta. Then we look at what they gave us. And let's see, SOHCAHTOA said that sine had to be opposite over hypotenuse. So I am just going to put whatever that numerator is as how big the opposite side is and how big the hypotenuse is. So the denominator, I'm just going to label the 17 on there. Now maybe it really was 16 and 34 on a similar triangle. I'm not going to worry about that. All similar triangles, this ratio would reduce to the same thing. So I'm going to do the easiest way possible and just pick the 8 and the 17 to be the lengths of two sides. Give me a thumbs up if you're at home, if that's making sense so far. Okay, so then we can use Pythagorean Theorem to figure out how long the other side is. So we know that 17 squared has to be 8 squared plus that adjacent side squared. And you may need a little bit of calculator help there. I don't know if everybody knows 17 squared or not. So you can punch that in on your calculator. James, you were punching in on the calculator already. What does a squared have to equal? What does a squared have to equal? 225. So that means a has to be 15. Now we can find the two missing trig functions, which means cosine of theta and tangent of theta. So cosine is adjacent over hypotenuse. So type in chat, what will this ratio be? How big is your adjacent side over how big is your hypotenuse? And what do we have? Hit enter. So adjacent is indeed 15, hypotenuse is 17, and then that leaves tangent. So tangent needs to be opposite over adjacent. So type in how long is your opposite side, how long is your adjacent side. And hit enter. And so opposite is indeed 8, adjacent is indeed 15. So great job. Thank you. You can just set it down and mess with it after a while if you want. Or if you really just want to do it. But or next period, I don't have anybody here today. So, all right, thanks. Anybody with questions? Okay, let me give you some directions on with your calculators. One thing you need to know before we start using the calculators. If you are using a TI Inspire, there is a, once it's turned on, your menu button. So from your home screen, you're going to push your menu button, and then it asks you for, or from your home screen, you can just push 5 for settings, and then you're going to choose 2 for document settings. And then where it says angle, you need to make sure that it says degrees and not radians. And then you want to click OK down at the bottom to make it your default. Let me see if I can stop sharing this one and share my whole screen maybe, at least briefly. That's not working. Is that not working? Let's see if it will work now. Okay, so now you can see my calculator there. So what you need to do is to hit your home button and then hit settings, or just punch in the number 5. And then we want 2 for document settings. This should be in float because that way we always get all of our decimal places. The second one is what needs to be degrees and not radians or gradients. Those are things that you'll learn about next year and beyond. But you don't need to worry about anything but degrees now. And then you'll go down and click highlight the OK to save that. If you have an updated system, not one of the older systems on there, it will also say degree up here in this upper right corner. If it says RAD, then you need to go in and change your settings or you will get totally incorrect answers on these. I do not have an 83, 84 that I can display, but on those on the front, if that's what you're using, there's a button called Mode, and then there's a place where you can choose degrees, and you'll have to use your arrow keys to go up and down and left and right to get to that, and then once the degrees is highlighted, you would push enter on that. So hopefully we're all good on that. So now let's take a couple of these that we want to evaluate using a calculator. So I'm going to model it with the Inspire, since that's what we would, in a normal year, be using in the classroom. So you can be in Scratchpad or you can be on a calculator page of a document. And then there is a button right here beside the 7 that says Trig. So you push on that. And then you've got a whole bunch of choices, more than we've actually talked about. We have only talked about sine, cosine, and tangent today. Next week, we will talk about these 3 that are right below those, that have the little -1s as an exponents. But for right now, if I wanted to evaluate tangent of 84, I would just go across until with my right arrow key, or it looks like I need to go up on mine, okay, until I get that tangent highlighted, and then I click enter, and then I have tangent with a parentheses, and all I have to do is type the 84 inside of there and enter, and then I would round and say that the tangent of 84 is 9.514. We are always going to use 3 decimal places. That wasn't back on pen. Why does this not want to work? So far, so good? Okay, next one is a little bit more complicated. We need to evaluate the cosine, or 3 times the cosine of 45.6. With an Inspire, all we have to do is type it exactly like that, 3. We don't even need the times. Why did I do that? If you're on an 83, 84, I think you would still then have to do the times button. Then we are going to go with trig, cosine, and then it's okay to type a decimal in there. So 45.6, enter, and we get 2.0989. So that 4th place is going to round that up, and we are going to say 2.099 when we've done our correct rounding. Okay, you guys go ahead and do this one on your own. Type it in chat. And let's see. Austin, what kind of calculator are you using? So you're using an Inspire and it's on degrees. What kind of answers did you get that were not correct? So for the second one, wow, that's way off. Did you put the 3 inside of the cosine? Or no, that wouldn't have been it. Look back at what the calculator says you actually entered. Mine had the 3 times cosine and 45.6 on the inside. Did you have something different out here, or did you have a cosine with a -1 on it? What's different about what your display says for what you entered on that? The 3 times cosine 45.6? If you were here, I'd just say, let me see your calculator, and I could figure out what was going on. Can you take a picture with your phone and send that to me as like an email attachment, and I'll get back to you on that while people are working on something else? That's about the best I can come up with to be able to see it and troubleshoot on that. All right, go ahead and hit enter for what you've got when you did 2 sine 25 degrees. And looks like we are unanimously in agreement that that is 0.845. So are we good with that? Anybody with questions?